Welcome back to another Tea Time with your favorite future Facebook, Amazon, and Google software engineer as a non-millionaire. Today we're actually going to be going over count primes, an easy problem on LeetCode, tough math problem. Okay, I know I said this is a tough problem. Incorrect use of words. I don't think it's tough. Maybe a little bit tricky or intimidating to some people. It's an easy problem, so it can't be that tough. I think the toughest part for me is figuring out how to explain this to you guys as easily as possible so it makes the most sense. So given count the number of primes less than a non-negative number n. So they give us an n, this is n, and the number of prime numbers less than n, less than 10 is 4. So we have 2, 3, 5, 7. Those are all prime numbers. Obviously we don't count 1 and 0. So let's go over to the whiteboard. I'm going to try and, oh, that was sweet. Did you guys see that? Yeah, I planned that. Just acted like I didn't. So one thing we could do is we could start a Boolean array. So I have a Boolean array here, and I labeled it. So 1 is true. Let's fill it all with true. And this is going to represent whether it's prime numbers. And then we could just loop through. We could loop through the numbers. So we would start at int I equals 2. Why 2, do you ask? Because we don't need to calculate for 2. We know 0 and 1 are not prime numbers, so we can just skip those. I think this is 10. So yeah, this is, we're going to start here. And this is not 0 indexed. We're going to create a Boolean array that is like, looks like Boolean, so prime. And then we're going to do new Boolean. It's going to be size n, so that's it. Technically, I mean, it is 0 indexed when you refer to it, but the way we're going to be looking at is it's not 0 indexed. We don't have to return the numbers that are the prime numbers. We just need to return the count, so we don't actually have to like keep track of which numbers are Boolean. And if we did, we could just subtract 1 or add 1. We would just add 1 if we needed to like figure them out, because this is we're using a non-zero indexed array. Hopefully that makes sense. So we're just doing new Boolean, and so that's our array. Then we're just going to fill it with all true, and then we're going to check the numbers. We're going to loop through all the numbers and see if we can get that number by multiplying 2 numbers. Then we're going to mark it as, we're going to change it to false. So we're going to like, for example, we'll see that 4 is not prime, so we'll just change it to 0, and then we'll keep a running count of, well, actually, since we're changing it from true to false, we're going to have a count of int count equals n minus 2. So we'll just subtract when we find a number that isn't prime. We'll just subtract instead of adding up. You could also do it the other way. I wanted to do it this way. And there's, and why n minus 2? Because like I said, we're not counting 10 and we're not counting 1. 2 obviously counts, so that's why we do that. So there's only 8 possible numbers. And technically, you could go to 5 and just, I mean, it's obviously not going to be, well, no, because we're just checking the numbers. Okay, so it's just 2 through 9 that we need to check. So that's why we have 8 for count. And now let's jump to the code. Well, I'm actually going to whiteboard this out more. So the first thing we're going to do is I by I less than n. So the reason for this is, if you think about it, 3 by 3 is less than n. You get 9. But as soon as you get to 4, there's no numbers that we can check that we haven't already checked. So 4 by 4 is 16. We're actually not going to need to check the 4s, because even though 8 is not prime and it's 2 by 4, we're already going to check it where int I equals 2. So that's the reason for that. And we're just going to I plus plus. And so yeah, I'm just going to start there, and then we can go, oh, it's on the over here. Okay, so let's code this out. So if n, let's do our base case first, is less than 2, then we just return 0. So like I said, I already mentioned this, I don't want to go over it again. Prime equals new boolean and a size of n. Okay, and so then we have int, or actually we're going to fill it with true first. So raise.fill prime true. And then we need to create a count, and it's going to be n minus 2. Remember, we're decrementing this. Okay, so let's do our first for loop. Okay, so the first thing we want to check is if we already did the numbers. So if prime of, if not prime, since we already have it all set to true, we want to check if it's not true. Then we just need to continue. So this, for example, is just checking numbers that we already checked, and then we want to do j equals I. So this is going to be like, so first we're going to start off 2 times 2 gives us 4, and so we're just going to do that. So we're going to do j times I is less than n. It's for the same reason. As soon as we reach a number past n, we don't need to check anymore, so that's the purpose of this. Okay, so the first thing we want to check is if prime of I times j is true. So this is saying if we get a number and it's true, we need to change it to false because it's not prime, obviously. So equals false. And then what do we need to do next? Well, we changed it to false, and we have our count set to all the true numbers. Well, we just decreased the true number, so we need to decrement count. And so that's like all the code. That's all the code we need, other than the return statement. Return count. So let's go over this. It's going to start at 2. And it's going to say 2 by 2, so it's less than 4. So we can keep going, and then it's going to say if 4 is if 4 is not prime, which it isn't, then we would continue. So let's go down here. It's going to say j equal to I, so 2 and 2 is less than n still, and it's going to check to see. So we get 4, and we see it's true, so we need to switch it to false and then decrement the count. And then j is going to increment by 1, so we do 2 times 3 and we get 6, and it's going to see that it's not, and then it's going to do j equals 4 and gets us 8. We're going to change that to false, so automatically this is going to become 0, 0, and 0. So now our count is 1, 2, 3, 4, 5. So count equals 5. Well, we still have one more because we know the answer is 4. They gave us to that in the problem. So now we're going to increment I. I is 3. 3 by 3 is less than n. So and 3 by 3 is not false. So we're gonna keep going. We're gonna execute this for loop. So we're gonna do 3 by 3. That's actually 9. So that's the number. We want to decrease count one more time, so we get it down to 4. And then we're gonna increment j and realize that 3 by 4 is greater than n. So it's gonna kick back out, and I is gonna be 4. Well, 4 by 4. We already executed 4 by 2, so that's why we're doing 4 by 4. Hopefully that made sense, and let's submit this. Okay, so this was running so much faster just a second ago. That's why I say it's literally the same code. I don't know what, and it was like 99%, whatever. So this is just O of n because we're just looping through Very few numbers. We're just looping through. It's like O of n divided by 2, but so is O of n. And the space complexity is linear as well, because we created a prime array and it's of size n. So I hope this video helped. If it did, smash that like button. Thanks for watching the video as always, and I'll see you in the next video. That's all I got for you guys.